Right, so we are continuing on with DeMoivre's theorems here. Now, on the video right before this was about powers. Now we are looking at roots. So it says, find all complex roots for the fourth root of z equals 1 minus I. So we're going to need DeMoivre's theorem. And now DeMoivre's theorem, it does on our formula sheet. The only one it gives you is it in cis form. So the formula is zk is the square, or the nth root of r times cis theta over n plus 360k over n. All right. Now remember that cis form just means it's cosine of all this plus I sine of all this. So instead of writing it twice, it's the exact same. If I go back to that last video, like we said, here's our formula. Same idea. It's r to the n of cosine of that part plus I sine of that part, which is written down as cis n times it. So it's the same idea. We're going to keep it in cis just because it's going to be a little bit easier. All right. So if I look here, my root, the fourth root, that means my root is the fourth, or n equals 4. Okay. So if it's at the square roots, it'd be 2 root. If it was a cubed root, this would be the 3. If it's a fourth, it's a fourth. The fifth root, and so forth. So n is going to be the root that we are. So n is 4. The other thing, though, is that this formula is in complex polar. This is in complex rectangular. So I need to get it in polar. In order to get polar, I need r and I need theta. So I'm going to go ahead and graph this. That is 1 in the positive, in the real direction, -1 in the imaginary direction. So 1, -1. So my r is root 2. And now my angle, you can choose anything you want for your angle. We'll say, hey, it's a 45, 45, 90. So that is 315. Or again, like we talked about in the last video, sometimes it's better to be in degrees, sometimes it's better to be in radians. We'll see which one is which. In this case, so this radians would be 7 pi over 4. Alright, so it's either one of those. So let's return z into complex rectangular. Again, this is complex. Sorry, this is complex rectangular. We need to go to complex polar. So z would be r root 2 cosine of 315 plus I sine of 315, which is cis 315. Or, again, this is in degree mode. We could put it in radians. It would be you could also write it like I was just going to put in the cis form for us. Root 2 cis 7 pi over 4. So either one, these are complex polar. Again, this is in degrees, this is in radians. Depending on the situation, one might be easier than the other. Okay. So let's go ahead and apply that formula straight up. We're going to use a cis form just to keep it a little bit simple for us. So we're not rewriting a bunch of stuff, but I'll do both of them. So you're actually finding the fourth root now. So that would be zk is equal to the fourth root of the square root of 2 cis 315, my theta, over n, which is 4, plus 360k over 4. Okay. Now here's the thing. 315 over 4. That's a pretty messy number. Can't do it with a calculator, and it's not going to simplify. So in reality, using the radian measures might actually be better. So zk equals the fourth root of root 2 cis 7 pi over 4 all over the 4th root plus 2 pi now, 2 pi k over 4. Okay. So although this looks a little bit messier at first, we can actually simplify some things, and we'll do that off to the side. First thing first, 7 pi over 4 divided by 4. Hey, that's a fraction divided by something, so I'm going to turn this guy into a fraction. To cancel it, I'm going to multiply by the reciprocal, right? If I multiply by 1 over 4 in the denominator, things cancel. But if I multiply the denominator by 1/4, I multiply the numerator by 1/4, so this is really 7 pi over 8. So that's just dealing with this part here. Okay, so let's have that. I'll try and color code some things of what I don't mess with. So this was in orange, this is that 7 pi. I didn't do anything, I just simplified. And I just simplified this little piece. The 2 pi k over 4, hey, 2 divided by 4, that's just going to become pi k over 2. Alright, so that's that piece simplified. Now I got to deal with this piece simplified, the 4th root of the square root of 2. Let's take the square root of 2 first. Another way to rewrite that, that's 2 to the 1/2. The reason is there's a little square inside of there. We don't write it often, but there's a square there. Alright, so it becomes 2 to the 1/2. Okay, so I now have the 4th root of 2 to the 1/2. Again, I could turn this into a fraction. This is a 4th root. That becomes 2 to the 1/2 to the 1/4. Alright, I turn this as the denominator to the first power. There. And now I'm going to multiply those together. If you can't see, sorry, this is a 2. Can't see. 1 is 2 to the 1/2. Now, when I have an exponent raised to an exponent, that becomes, you multiply them. So it'd be 2 to the 1/8. Or, we can go the other way, the 8th root of 2. So I haven't done anything, I've just simplified right now. Just simplified some of those numbers. I'm actually going to go one step further. Well, we'll see why. Okay, so I have everything figured out here except for k. Now, what k tells you is, depending on the root it is, tells you how many roots there are going to be. If there's the 4th root, that means there's going to be 4 answers. How do you get those 4 answers? You plug things into k. Okay, like I said, if it's the 5th root, it would be, you'd have 5 answers. If it was the 6th root, you'd have 6 answers, and so forth. Now, since it's the 4th root, the question is, what k values do you pick? In reality, you are allowed to pick any k values you want as long as they are consecutive. What that means is they come one after each other. So you could do 1, 2, 3, 4. You could do 6, 7, 8, 9. You could do 20, 21, 22, 23. Whatever you want, as long as they're 4 numbers in order. But remember, you're plugging that into here. Okay? So you want to pick k values that are very nice. So the best k values to pick are 0, 1, 2, and 3. All right? Since we're doing the 4th root. All right? So I'm going to start off by doing my first one would be like, hey, z0 would be the 8th root of 2, cis 7 pi over 8 plus pi over 2 times 0. Okay, that's going to cancel out, so my answer is just going to be the 8th root of 2 cis 7 pi over 8. That's one answer. Okay. My next one would be like z to the first 8th root of 2 cis 7 pi over 8 plus pi over 2 times 1, which is pi over 2. Now, I do have to add these together. So it's actually going to help us if in here we do one more step to help us out. We are going to rewrite this with common denominators. So I'm really going to use zk is equal to the 8th root of 2 cis 7 pi over 8 plus, to common denominators, I need to multiply this by 4 and 4. This is 4 pi k over 8. And just to help us out. So when I do this one in red, actually, it would really be 4 pi over 8, which now is easier to solve. 7, I can add them because they're common denominators. 11 pi over 8. So that's the second one. We'll get the next one, C2. So now I'm going to do 2 times, so it's 4 pi times 2 over 8. So that's going to give me 8 pi. So this is going to be, well, this is 2 times 4. This would be 8 pi over 8. So I'm going to have 8 pi plus the 7 pi. So that would be 15 pi over 8. Alright, so I have 1, 2, 3. Remember, I need the fourth one. So I need z to be 3. That'd be the 8th root of 2. Cis. So that'd be 7 pi over 8 plus, if I had a 3 here, right, k is 3 now. So 3 times 4, that's going to be 12 pi over 8. So to simplify that, 8 root 2 cis, 7 plus 12, that is 19 pi over 8. And those would be my 4 answers. So when it says find all roots of the complex number, so we're finding all the 4th roots here because that's what the question asked for. I have 4 answers, 1, 2, 3, 4. All right, and again, I chose to do it in radians just because it's going to be a little bit easier than dealing with this pi over 4, or 315 divided by 4 with it in degrees. So you can do either one. It just depends on the situation. One might be easier than the other.